Alright, so this is the section 4 study guide video. Um, you will be able to use this if I get a good note, and on top of that, if it is complete. So you need to make sure that you watch the entire video. Alright, so let's get started with graphing the set of ordered pairs. Very easy question for us to get. All we are doing is we have to graph this on a coordinate plane. So I gave you a graph sheet right here. So all you got to do, draw a line this way and draw a line this way. Okay. My numbers don't have to be really large because the highest number that I have is a positive 4 and the lowest number I have is a negative 3. So I do not need to go super high. So 1, 2, 3, 4, and 5 is good enough. Then I have 1, 2, 3, 4, and 5 is good enough as well. I have a negative 1, negative 2, negative 3, negative 4, and negative 5. Negative 1, negative 2, negative 3, negative 4, and negative 5. Okay. Again, you don't need a super large one because my numbers are not large. So, let's actually number these 1, 2, 3, 4, and 5. Then I have up 1, 2, 3, 4, and 5. If I go down, they're negative, negative 1, negative 2, negative 3, negative 4, and negative 5. If I go to the left, they're also negative, so I have a negative 1, a negative 2, a negative 3, a negative 4, and a negative 5. Alright, so now I'm going to graph these ordered pairs. So the first one, remember that ordered pairs has an x first and a y second. Ordered pairs are always x first, y second. So the ordered pair is negative 2. Next thing I need to know is what axis goes from left to right. So what axis is this axis right here? Well, that's my x-axis. And what axis goes bottom or top to bottom? And that's my y-axis. So my first point says negative 2 on the x-axis. So I go 1, 2 left. And then it says go down to negative 3. Well, negative 3 is down here. So that's my first point. So again, I went to the left to negative 2 and down to negative 3. The next one says on the x-axis I'm going at 0. And then I got to go down to negative 1. Right here. The third one says go to 1 first. So 1 is right here. And stay at 0. So that's right here. The third one is 3 and 2. So go to 3. So 3 on the x-axis is 1, 2, 3. And then up to 2, 1, 2. Last but not least is 4 and 4. So go to the right over to 4. Go up to 4. Alright. Last but not least, all I got to do is connect my dots. Alright. Now, when you guys go and graph this on the test, it'll actually look a lot more straight. But this is what we call a straight line. Okay. So the set of points is blank. Our responses can either be a linear function, a function but nonlinear, or not a function. Well, a linear function just means a straight line. A function but is nonlinear, remember, could be something like that. But not a function is something like this. So which one does it look like? Well, it looks like a linear function. So that would be our first choice. Okay, remember straight lines are linear, non-linear, but it is a function, looks like a U, and a not a function, looks like a backwards U. Alright, let's move to number 3. Which of the following relations are functions? Select all that apply. So, as we talked about a little bit earlier this year, we talked about domains and ranges. Domains is another name for X. Therefore, range is another name for y. And remember, x is not allowed to cheat. What that means is my x can only go to one of my y's. So currently, this 6 is going to this 5 and this 4. So because it is dating, you can say, 5 and 4, it is cheating. And therefore, because x is not allowed to cheat, this is not a function. Let's look at C, x and y. Well, -2 is only with 0.5, so that's good. 0 is only with 2.5, that's good. 4 is only with 6.5, and 5 is only with 2.5. Now, the question, 2.5 has 0 and 5. Is that allowed? Yeah, it's allowed because y is allowed to cheat. Alright? Y can have as many numbers on this side as it wants. X cannot. So therefore, C is a function. Let's continue. This one right here. Would this be considered a function? Well, if I did my vertical line test, no, that is not a function. Remember the vertical line test, vertical line test is a test that we do. It's just a straight line, and if it hits only one time, like this right here, it is a function. So D is also a function. But if it hits more than once, it is not a function. Okay, let's move on to question number 4. Given the relation below, identify the domain and range and tell if the relation is a function. Okay, so let's identify the domains and ranges. So remember, domain is another name for x. Range is another name for y. So the first thing I got to do is label all of these x and y's. X and y, x and y. And as we just said, domain equals x, range equals y. So let's jump down to number 5 before we jump into 4. So number 5, what is my domains in this problem? Well, I have -3, I have 2, I have 1, and I have 4. Again, I have -3, I have 2, I have 1, and I have 4. All of those are my domains. Now, what about my ranges? Alright, my ranges, I have -3, I have 0, I have +3, and I have 4. But here's the thing, it says place the numbers in order from smallest to largest. So my smallest number is -3, then 1, 2, and 4. This one, I have -3, 0, 3, and 4. So let's determine, is this a function or not? Well, is any of my x's cheating? Do I have the same x cheating with another number? So -3 only has -3. There's no other -3's here. 1 only has 3. 2 only has 0. And 4 only has 4. So therefore, this is a function. It is a function. Alright, so we learned that one. That one's another easy question. All right, number 6, find the range of the function for the given domain. Again, a range is just the y's. They give us the domains. We talked about this in class as well. So those are our inputs. Now we just need to find our outputs. So the first input it wants us to give is 2. So I use f of 2. That means anytime I see an x, I'm going to put what number? I'm going to put 2. So I put 2 times, so all I'm doing is 2 times x. I see an x, so what am I going to put? I'm going to put a 2. Then what's the rest of the problem say? Minus 1. So what is 2 times 2? Well, 2 times 2 is 4. And then I just drop down the minus 1. 4 minus 1 is 5. Oh my gosh, 4 minus 1 is not 5, it's 3. My apologies. Alright, so that was our first one. Now let's do the 0. I'll do this in a different color. So the next one is f. That was not supposed to be red. F of 0 equals, so every time I see an x, I'm going to put what number now? I'm going to put 0. 2, I see an x, so it's 0 minus 1. Well, anything times 0 is 0. 0 minus 1, that is negative 1. I can cross out my 0 because I'm done with that now. The last one I need to do is negative 1. So f of negative 1, that means anytime I see an x, I'm going to put what number? Negative 1. So that is 2 times negative 1 minus 1. Well, 2 times 1 is 2, but a negative times a positive is a negative. So 2 times negative 1 is negative 2. Then I drop down my minus 1. I borrowed $2 from somebody, and then I asked that person for another dollar. How much money do I owe them? I owe them negative $3. So this and this are my answers. So it says place the orders in order from smallest to largest. So the smallest number I have is negative 3. The second smallest is negative 1. The last one is 3 because that's my largest number. And there we go. This is my answer. Okay, let's move on to question 7. If f of n equals negative 5x plus 3 and f of n equals negative 47, what is the value of n? This right here should have been n. So I apologize on that end. I thought I fixed that. Okay. So if f of n equals negative 5n plus 3 and f of n equals negative 47, what is the value of n? So what does this mean? So this is saying that if f of n equals negative 47, what is n? So I'm going to replace my answer with negative 47. So how is that going to look? Well, instead of f of n being here, I'm going to put negative 47. Negative 47. So I'll reteach that right now. This right here matches this right here. So what does this equal? Well, the problem says it equals negative 47. So that means I can replace that with f of n. Okay, so now negative 47 equals negative 5n plus 3. Okay, so what variable am I solving for? Well, I'm solving for n. So what's the first thing I have to do in order to solve this problem? Let's go ahead and let's separate it first. I need to get n by itself, so how do I get rid of this negative or this positive 3? Well, I subtract it. Okay, and so what happens with these 3's? They cross out. I can drop down my negative 5n equals, well, negative 47 minus 3. So that's saying I had $47, or sorry, I owed somebody $47. I asked them for $3 more. How much money do I owe them? I owe them $50, and since I owe them a negative 50. My last step would be to divide by negative 5. So, negative 50 divided by 5 gives me an answer of positive 10, because a negative divided by a negative equals a positive. So this is my answer. Okay, there's another problem just like it, except this one doesn't say that f of x equals. This one says, what is f of negative 2 for the function f of x equals negative 4x plus 3. So really quickly, notice the difference between these two questions. One of them has this value right here. The other one has the answer. So notice how these two are different. Okay? So this time, instead of putting negative 2 as my whole answer, what place is negative 2 taking in this problem? Look at this. This says f of negative 2. So what is it replacing right here? What is that number replacing for this right here? Well, it's replacing the x. So let's rewrite this, but instead of x, I'm going to put negative 2. So f, instead of x, I'm putting negative 2. So that means anytime I see an x, I'm going to put negative 2. So negative 4 times negative 2 plus 3. So right here, negative 4 times negative 2. Well, negative times a negative is a positive, and therefore 4 times 2 is 8. Then I do plus 3. Now my answer, 8 plus 3, is 11. So my final answer is 11. Okay, pretty easy problem. You just need to know the difference between the answer, f of n, and f of negative 2. Alright, number 9. Find the function that represents the relationship below. So here's how this problem works. We need to find the pattern. So what is the pattern here? What is each one going by? Well, negative 6 to negative 4, 4 to 0, 0 to 2. So what is happening each time? Well, negative 6 to negative 4 is a difference of a positive 2. And then negative 4 to 0, though, is not a positive 2. But look right here. Is that in order? This one went negative 1 to 0 to, and it skipped a number. So this is actually going up by 4, and this one is going up by 2. This one to this one to this one, negative 1 to 0 is a plus 2, because negative 1, sorry, plus 1. 0 to 2 is a plus 2. And 2 to 3 is a plus 1. So you see how it skipped? If I didn't skip, it would have been a plus 2. So that's okay. So my pattern is plus 2. So that means my change, my rate of change is 2. My rate of change is 2. So that means, is it negative 2? No. Is it positive 2? Yeah. Is it 1/2? No. Another thing to look for is look for where x is 0. X is 0 right here. So because x is 0 right here, this answer is negative 4. Look at this. Negative 4 is right here. So 2 is my rate of change, and negative 4 is my when x is 0. Alright, let's move to number 10. The number of students seated in each row of an auditorium form an arithmetic sequence as shown in the table. How many students are seated in the 20th row? So arithmetic sequence is what we just talked about last unit before you got your study guides. So the first thing for arithmetic, first thing is find the difference. Okay? Does anybody remember the formula? The formula for an arithmetic sequence is going to be A of n equals A1 plus n minus 1 times the difference. Now A1 stands for the first term. N stands for the term you are solving for. And D stands for the difference. Alright, so the first thing we need to do is find our difference. So 4 to 7, 7 to 10, 10 to 13. What is happening each time? Well, 4 to 7, that is a 3. 7 to 10, that's a plus 3. 10 to 13, that's a plus 3 again. So that works. So my difference equals 3. Now, second thing is plug in my variables. So let's try this. A of n, so I'm going to use my formula to plug in my numbers. A of n equals, what is my first term? Well, let's look. My first term is 4 plus n. Well, n stands for what? The term you are solving for. So the term I'm solving for is the 20th. So it's 20 minus 1 times the difference. Well, what's my difference? My difference is 3. So now I need to solve this. First thing I need to do is parentheses. 20 minus 1. 20 minus 1 is 19. And then let's drop everything else down. Oops, I'm sorry. Everything else down. Okay, now the next thing I need to do is I need to multiply my 19 and my 3. So 19 times 3 is 57. And then plus 4. 57 plus 4. Well, 57 plus 4 gives me an answer of 61. So how many students are seated in the 20th row? 61. Alright, we really need to remember the formula. And let's move on. What is the graph of 3x minus 4y equals 6? Okay. So in order for us to do this, we need to look at putting this into slope-intercept form. Now this is something that we haven't learned in this unit, but it will be on the test. So 3x minus 4y equals 6. Okay. Now, all I need to do is get my y by itself. Get this y by itself. So that means I need to move this one, and I need to move this one. How do I move this 3x to the other side? Well, I got to subtract it. Negative 3x, negative 3x. I can cross those 3x's out and I drop down my negative 4y. 6 and negative 3x, are they like terms? No. So I need to keep it 6 minus 3x. Last but not least, I divide everything by negative 4. Those 4's will cross out. You are left with y equals 6 divided by negative 4. Well, it doesn't go in evenly, but it's a negative 1 and 1/2. Because it would be 2 over 4, which is 1/2. And then negative 3 and negative 4 would equal a positive 3 over 4. This is rise over run, which we'll learn more about next unit. So I need to look for one that has a negative 1 and 1/2. This one right here goes at 1 and in between 1 and 2. So that's good. This one starts at 0, 0. This one starts at 1 and negative 1. So this is 1/2, negative 1/2. So maybe either A or D, I'm sorry. And this one is 0, 0. They start at 0, 0. So the next thing we need to look for is my slope. So from this point right here, my slope is positive. So positive lines look like this. Negative lines look like this. So my slope is positive, therefore A is my correct answer. That's more of a harder question for this unit because we haven't learned this, so it's okay. Let's move on to number 12. Number 12 says the equation 2x plus 6y equals 115. Represent the number of bags of sand, x, and bags of mulch, y, that can be bought with $115. If no bags of sand are bought, how many bags of mulch can be purchased with $115? So my formula is 2x plus 6y equals 115. So it says that x stands for sand. This is important. And y stands for mulch. And it says if no bags of sand are bought, so that means if my x was 0, what would be, how many bags of mulch can I buy? So let's do, if x is 0, so 2 times 0, again, if x right here is 0, how many mulches of sand can I buy? Or sorry, of mulch can I buy? So anything times 0 is 0. So it's just saying, what is 6y equals 115? How do I get rid of the 6? Well, I simply just divide it. Those 6's will cross out. Y equals 115 divided by 6, and that's about 19.16. So if no bags of mulch are bought, how many bags of if no bags of sand were bought, how many bags of mulch can be purchased? About 19 bags. Okay, let's move on to number 13. A lawn care company charges a $15 trip fee plus 25 cents per square foot of X feet of lawn for fertilization. Which equation represents this relationship? Alright, so first off, it's saying a lawn care company charges $15 trip fee. So no matter what, we're going to be paying $15. Then it says plus, it tells you right there what to do next. So 15 plus 0.25 per square foot of X. So 0.25 X equals, well, it would equal my Y value because Y stands for my total. So which equation looks like this? Well, A is wrong. B, well, that looks good. Y equals 0.25x plus 15. That's correct. Let's move on to 14 and 15. The following set of ordered pairs below represents a function. Write a function rule for the function. So, first off, we need to find the difference between 1 and 17. So these are actually not in order. So let's put them in order first. So I have my x's and I have my y's. So the first one is 0, okay, and that value is 1. So I can cross that out. What's after 0? Well, 1 is after 0. So 1 and 5. So they try to trip you up. Don't get confused. The next one after 1 is 2. So 2 to 9. Next one is 3. 3 to 13. Last but not least, 4 to 17. Okay, so what is my difference between these ones? 1 to 5, 5 to 9, 9 to 13, and 13 to 17. So 1 to 5 is a difference of 4. 5 to 9 is a difference of 4. 9 to 13 is a difference of 4. And 13 to 17 is a difference to 4. So this difference right here, these 4's, is my x value right here. So this right here is 4. The next part of this is look for the one where x is 0. So which one has x as 0? 1. So you're going to put that value in for the 15. So 1 goes right here. So this value goes there. And it's that easy. That's it. Okay, let's move on to graph the function f of x equals 4x minus 1. So, first thing we need to do is create a table. Alright, so remember I only want 3 points. So we start with our x, then we start with our function f of x equals 4x minus 1, and then we have our ordered pair x and y. Okay, easiest one to start with is 0, because anything times 0 is 0. So I have f of 0 equals, anytime I see an x, I'm going to put a 0, so 4 times 0 minus 1. 4 times 0 is 0. 0 minus 1 is negative 1. So your input was 0, your output was negative 1. Another easy one to do is 1. Anything times 1 is itself. So every time I see an x, I'm going to put what value? I'm going to put 1. So f of 1 equals 4. I see an x, so I'm going to put a 1 minus 1. 4, because 4 times 1 is 4. 4 minus 1, 4 minus 1 is 3. So what was my input? My input was 1, my output was 3. Last but not least, I think another easy one is 2. So every time I see an x, I'm going to put a 2. So f of 2 equals 4 times 2 minus 1. 4 times 2 is 8. 8 minus 1 is 7. So my input was 2, my output was 7. So how do I graph this? Well, let's do a number line right here. And let's do 1, 2, 3. Let's actually separate them a little bit more. 1, so I'll skip a line. 2, I'll skip a line. And 3. On these ones, let's go to 1, 2, 3, 4, 5, 6, 7, and 8. And then here I skip 1, 2, negative 1, negative 2. Alright, so this is 2. This is 1, 2, 4, 6, and 8. Alright, so let's do our first ordered pair. Our first ordered pair is 0 and -1. So 0 is right in the middle, and then -1 is down. Because remember, this is my x, this is my y. My next point is 1 and 3. So 1 is on my x value, so it's just 1 over. And then 3 is up. So this is 2, this is 3 right here. The last one is 2 and 7. So 2 is just 2 over on the right. And go up to 7 right here. Connect my dots, and I am done. That is how you graph a function. Alright, let's go to 17, sorry. Graph a function to represent y is more than the product of 2 and x. Y equals 3 more, so 3 more is plus 2 times x. Y is 3 more, so 3 more, which is 3 plus. The product means multiply, 2 and x. Okay, so now let's create our function table. So I create a table, x right here, and our ordered pair x and y. So the first value I need to do is put 0, because 0 is the easiest. So every time I see a 0, I'm going to put every time I see an x, I'm going to put a 0. 2 times 0. So 2 times 0 is 0 plus 3. 0 plus 3 is 3. So my ordered pair, my input was 0, my output was 3. My next easiest one is 1. So every time I see an x, I'm going to put 1 this time. Y equals 3 plus 2 times 1. 2 times 1 is 2, plus 3 is 5. So my input was 1, my output was 5. And last but not least, the second easiest one is 2. So y equals, every time I see an x, I'm going to put a 2. 3 plus 2 times 2. 2 times 2 is 4, plus 3 is 7. My input here was 2, my output was 7. So let's go ahead and let's create another table or graph. Okay, let's label these. The reason this video is a little bit longer is because we're graphing. We're on the computer, you'll already have a graph that you just draw a line on. Okay, so I have 1, 2, 3, 4, 5, 6, 7, 8. So we'll do 2, 4, 6, 8. And then I have, let's do 2, skip 2. So it's 1, 2, and 3. Then I have 1, 2, 3, and 4. So it's -2, -4. And then 1, 2. -1, -2. Alright, so my first ordered pair is 0. So 0 is right in the middle, and then go up to 3. So 1, 2, and 3. Okay, the next one is 1 and 5. So 1 is on the right, up to 5. And last but not least, 2 and 7, 2 and 7. Draw my straight line, and I am done. Okay, remember you can always rewind or pause the video at any time. Okay, the price of P, sorry, that did not sound. The price P of a club's membership is $35 for an enrollment fee of for an enrollment fee and $14 per week W to be a member. Write a function rule that describes the scenario. What is the price for 7 weeks of membership? So first thing, let's create our function. So there is a membership fee just to enroll. What is that? Well, that's a $35 fee. No matter what, you're going to have to pay $35. And then it's $14 per week, and W stands for the week. So which one should be attached to the W, the 14 or the 35? Well, that one's easy, the 14. The 35 should be by itself. So the problem says, what's the price for 7 weeks? So instead of putting a W, I'm going to put a 7. So it should be 14 times 7 plus 35. And 14 times 7 is 98 plus 35. 98 plus 35 is $133. And that's it. Pretty easy question. Let's move on to 21. You buy X pounds of cherries for $4.99. What is a function ruled for the amount of change C you receive from a $20 bill? Alright, so if I have a $20 bill and I buy some cherries, so I start with the 20. What's going to happen if I buy more cherries? It's going to be subtracted from it. And how much is the cherries? Well, the cherries are $4.99 per pound. So per pound is X. Which one of these matches which one of these? So the first one is 4.99x minus 20. That doesn't work. Okay. The next one is C equals 20 minus 4.99x. That seems to work. So B would be our answer. Okay. Determine which functions are arithmetic. Select all that apply. So remember, arithmetic means that if they have a pattern that is adding, or subtracting. So I can't be multiplying. So 3 to 6, 6 to 12, and 12 to 24. 3 to 6 is, well, I would add 3. But 6 to 12 is not adding 3. So this one would not be arithmetic. Okay, next one. 1 to 5, 1/5. So that's a plus 1 over 2. So all we did was added 2 to it. 7 to 9 is an add 2. 9 to 11 is an add 2. So you see how that all worked? Just because it's a fraction does not mean it can't be arithmetic. So that works. -7 to -3, -3 to 1, and 1 to 5. So this is -7 to -3. Well, that's a plus 4. -3 to a positive 1 is a plus 4. And 1 to 5 is also a plus 4. So this one is also an arithmetic. Alright, -10 to 5. So -10 to a 5 would be a -15. A 5 to a -2. -5 over 2. Right away I can tell this is not arithmetic. You go from a whole number to a fraction, doesn't work. Next one is 10 to 6, 6 to 2, 2 to -2. So 10 to 6. How would I go from 10 to 6? Well, I would subtract it by 4. 6 minus 4, does that give me 2? Yeah, it does. So a minus 4 again. Does 2 minus 4 give me -2? Yeah, it does. So that one is also an arithmetic. So 0 to 1/2, 1/2 to 1, and 3 to 2. Right away I can tell we're going from whole numbers to fractions. This may or may not work actually because of the fact that 0 to 1/2. Well, if I add 1/2 to 0, I get 0 to 1/2. What if I add 1/2 to 1/2? Well, it gives me 1. So that one works too. What about 1 to 1/2. Does that work? So 1 plus 1 over 2. If I do that, and then I go ahead and I multiply this one by 2, multiply this one by 2, that's 2 over 2 plus 1 over 2. 2 plus 1 is 3, 3 over 2. Well, yeah, that worked. So F is also correct. Alright, so just because it's a fraction does not mean it can't work. Let's move on to question number 23 and 24. Use the sequence 11 to 14, 17, and 20 to answer the following questions. Find the next 3 terms of the sequence. So first off, 11 to 14, 14 to 17, and 17 to 20. What is my rate? What's my change? What's happening here? What's my difference? Well, it's plus 3, plus 3, plus 3. So find the next 3 terms of the sequence. So if I add 3 to the next one, what would that be? Well, the next one would be 23. After that, 23 would be 26. And after the 26 would be a 29. So far that's 1, 2, 3, 4, 5, 6, and 7 terms. Now, I have 2 choices. I could go all the way to the 12th term by keep on adding 3. Or I can use the explicit formula. Remember, explicit formula is A of n equals A1 plus n minus 1 times the difference. So just for more practice, we're going to use this one. If you absolutely don't remember this, just keep on adding 3 until you get to 12. So I'm trying to find the 12th term, so A1 is the 11 plus the 12 minus 1 times the difference. The difference is 3. So 12 minus 1 gives me an answer of 11. Times that by 3 and add it to 11. 11 times 3. Well, 11 times 3 is 33. Equals, I'm sorry, not equals, plus 11. 11 plus 33 is 40. I don't know what I was doing. 44. And my 12th term would be 44. Alright, so what is the nth term of the sequence? So this is basically just asking me, how do I get to, what's my formula here? So my difference is 3. So my difference has to have whichever formula this is. So this is a plus 3 here, plus 3 here. This is a plus 20. No, not what we want. Plus an 11, not what we want. And plus a 14, not what we want. So my 2 options are going to be 9 or n. Well, 9, I'm not sure where that comes from either. So n, all I'm going to do is find whatever my term is plus the 3. That's what we did up here. I take my last term and I add 3 to it. That's it. Okay, and that is our last question. I apologize that this video was so long, but it was a long study guide. Go ahead and make sure you study as much as you can and make sure it is complete. I will be checking these for credit. You guys have a great weekend, and I will see you on Tuesday for your test.